Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about acceleration in 2 dimension for NEET and JEE exam. First of all, I will discuss the theory and next I will discuss about the problems. Okay, what is acceleration? If the velocity changes, we say that there will be an acceleration. So, acceleration is equal to change in velocity divided by change in time. Okay, the change in velocity may be due to change in the magnitude of velocity or change in the direction of velocity or changes in both magnitude and direction. So, if a body is moving in a plane, this is the x-axis and here is the y-axis. The body is moving like this path. Initial point is p1. The velocity at this point is tangent at that point, that is p1. After delta t time, the body is at this point p2. The velocity is like this. Okay, this is the v1 vector and this is the v2 vector. So, what about the change in velocity? Change in velocity is equal to final velocity minus initial velocity. Okay, then the velocity will be changes when the body is moving from one point to another point. So here we can say that the body has some acceleration. The acceleration is equal to change in velocity divided by time. So the acceleration direction is equal to the change in velocity direction. We will see that. So the v1 vector is like this and the v2 vector is like this. Okay, if I will draw a vector like this, that we can consider as the change in velocity, because if you apply the triangular law of vector addition here, v1 plus delta v is equal to v2 vector. Okay, from this delta v is equal, what you will get? v2 vector minus v1 vector. Okay, that only we need to find out. Okay, so here you see that the change in velocity is in this direction. So the change in velocity is like this direction. So the acceleration direction is like this. Okay, this is the acceleration in a particular interval of time. So this is the average acceleration. Average acceleration. If we find out the acceleration at a particular instant, that acceleration we call it as instantaneous acceleration. Instantaneous acceleration is the acceleration at a particular instant. So that is a limiting case of the average acceleration. So limit as delta t tends to 0, delta v divided by delta t. That is equal to dv divided by dt. Okay, this is the instantaneous acceleration, dv divided by dt. So here the velocity is a function of time. This is the instantaneous acceleration. Okay. Then what about the direction of instantaneous acceleration? So you consider at a point here. In this point P1, the velocity is in this direction. So the acceleration direction is perpendicular to this, like this. This is the acceleration at this point. Okay. Then what about the acceleration at this point? At this point is perpendicular to the tangent, that is in this direction. This is acceleration at this point. Okay, this is the direction of instantaneous acceleration. Okay, next we will see equation of motion. Kinematic equation. If a body is moving in a plane with a constant acceleration, the velocity at any instant have two components and the position at a particular instant also have two components. Okay, so that motion we can consider it as the combination of two independent motion. One is along the x direction and another is along the y direction. Okay, so the velocity after a particular instant we can write it as v is equal to v naught plus at. Okay, v is the velocity after t time, that is equal to vxi plus vy and the v naught is the initial velocity vector, that is equal to v naught xi plus v naught yj. Okay, and the acceleration is equal to axi plus ayj. Then the component of velocity along the x direction is v naught x plus axt. Okay, and the component of velocity along the y direction after t time is v naught y plus ayt. Okay, and this is the first motion equation and the second motion equation. Okay, the position vector of a body after a t time r is equal to r naught plus v naught t plus half into at square. Okay, r is a position vector after t time, so that is equal to xi plus yj, and r naught is equal to x naught I plus y naught j. Okay, v naught is the initial velocity vector, a is the acceleration. Okay, so x we can write it as x naught plus v naught x t plus half into axt, and similar way y is equal to y naught plus v naught y t plus half into a by t square. This is also t square. This is also t square. Okay, this is the second motion equation, and the third one, v square is equal to u square plus 2a into r vector minus r naught vector. Okay, clear? These are the kinematic equations of motion we can apply in a uniform accelerator motion in a plane. Okay, this is about the theory. If you want to know the detailed theory, please visit my channel and go to the chapter motion in a plane. Okay, then now we will see the problems. First of all, type 1. A particle has an initial velocity 3i plus 4j and acceleration 0.4i plus 0.3j. Its speed after 10 seconds is. They given that the particle is moving with an initial velocity. Initial velocity we have taken as v naught is equal to 3i plus 4j. Okay, and the acceleration is 0.4i plus 0.3j. Okay, the speed after 10 seconds we need to find out. Okay, so the velocity after t time is v is equal to v naught plus at. Okay, all the values are given. We can directly substitute it, and you can find out the magnitude of the velocity, that is the speed. Okay, so here you will get 3i plus 4j plus the acceleration is 0.4i plus 0.3j into 10. We can multiply the 10 inside, so 3i plus 4j plus 4i plus 3j. Okay, so the velocity is equal to 3i plus 4i, 7i you will get, plus 4j plus 3j, 7j. This is the velocity. The magnitude of the velocity is square root of 7 square plus 7 square, that is equal to 7 root. Okay, that is the magnitude of the velocity. Okay, this is about the type 1. Now we will see type 2. If r is equal to 2 cos theta I plus 6 sin theta j, the acceleration at theta is equal to pi by 2 is. Okay, so we know that the acceleration is equal to d square r divided by dt square. Okay, first of all I will find out the dr divided by dt, that is equal to the differentiation of this. So 2 cos theta, the cos theta differentiation is minus sin 2 theta, okay, into 2, okay, into I plus 6 into the derivation of sin theta is cos theta j. Okay, this is the dr by dt, that is equal to minus 4 sin 2 theta I plus 6 cos theta j. Okay, then d square r divided by dt square is equal to, again you differentiate it, so minus 4 into sin theta differentiation is cos theta. Here cos 2 theta you will get into 2 you will get. Okay, I plus 6 into cos theta differentiation is minus sin theta j. Okay, then here you will get as 8 cos 2 theta I minus 6j you will get. Okay, this is 6j sin theta you will get. Okay, 6j sin theta j. Okay, this is the acceleration vector. They are asking you to find out the acceleration at theta is equal to pi by 2. Okay, we can substitute it. So minus 8 cos 2 into pi by 2 I minus 6 into sine pi by 2. Okay, sine pi by 2 into g. Okay, so here this 2 and 2 we can cancel it. So cos pi you will get, cos pi is equal to minus 1. So you will get as 8i you will get. Okay, minus 6 into sine pi by 2 value is 1. So minus 6j you will get. This is the acceleration. Okay, then if you are trying to find out the magnitude of acceleration, the magnitude of the acceleration is equal to square root of 8 square plus 6 square. Okay, so 8 square plus 6 square is equal to, you will get it as 64 plus 36. So that is equal to 100. That is 10 meter per second square. That is the acceleration. Okay. This is the type 3 problem. A particle moving eastward with a velocity of 5 meter per second. In 10 seconds, the velocity changes to south direction. The same magnitude, the average acceleration, we need to find it. Average acceleration is equal to change in velocity divided by time. Okay, so we will find out the change in velocity. This is the east direction, this is the west direction, this is north and this is south. Okay, initially the body is moving toward the east direction like this. After that it is changes to south direction like this. Okay, then this is a V1. V1 is 5 meter per second. What about V2? V2 also 5 meter per second. Okay, then acceleration is equal to change in velocity divided by time. What about change in velocity? That is equal to final velocity vector minus initial velocity vector. So here V2 minus V1. This we can write it as V2 vector plus minus V1 vector. Okay, so the minus V1 vector is the negative vector of the V1. It is all the same magnitude but in the opposite direction. Like this you will get. Okay, so you can form a parallelogram here. The diagonal of the parallelogram is the resultant. That is equal to V2 vector minus V1 vector. That is the resultant. Okay, so from this delta V magnitude is equal to square root of V1 square plus V2 square. Okay, so what about V1 value? That is equal to 5 square and V2 also 5 square. So you will get as 5 root 2 you will get. In the which direction? The direction is in the southwest direction. Southwest. Okay, meter per second in the southwest direction. Okay, that is a change in velocity magnitude. We need to find out the acceleration. So acceleration is equal to delta V divided by delta t. So you will get 5 root 2 divided by 10. So 0.5 root 2 meter per second square in the southwest direction. Okay, this is the acceleration. Okay, that's all about this topic.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.